The third property we are going to start with is an oxidation. You know that oxidation is such a property that we can even distinguish between aldehydes and ketones also. So just we will see that what kind of oxidation products they can form actually. So we see that whenever we take an aldehyde and we oxidize it, oxidation of aldehyde is quite easy, and it can occur in presence of oxidizing agent KMNO4 or K2Cr2O7, any of them can be used, and it turns into a carboxylic acid, right. But so this is an easy, because here the H of an aldehyde easily get converted into OH. That means the conversion of H into OH is quite easy here. But here if you see ketone, the conversion of this CO is actually difficult into OH. So what happened here, actually CC bond gets break up. In this, the CC bond actually gets break up. It shows, it forms a carboxylic acid, but the carboxylic acid formed is actually less than, it contains the less carbon atom as present in a parent aldehyde, right. So it will break up. That means the CC bond will break up and it will form an acid which will have a different number of you can say the carbon atom as present in parent aldehyde. And moreover, the oxidation take place in a powerful oxidizing agent, can be KMNO4 in sulfuric acid, can be K2Cr2O7 in sulfuric acid, can be concentrated HNO3. Right. So these powerful oxidizing agents are required here, and like this is in case of symmetrical ketones, that it is simple that you will convert, these two groups are same. So you will convert either of them into one acid and the rest of them in another acid. But suppose if you have an unsymmetrical ketone, suppose this is my unsymmetrical ketone. So here also it will get converted in presence of this thing, powerful oxidizing agent. But here the point is that, like with which group, as they both are different, so with which this CO bond will go, this ketone group will grow with which alkyl group. So here we follow a Pope's rule, which states that the ketonic group will go with the alkyl group which contain less number of carbon atoms. So as you can see that this contain less number of carbon atom, so it will go with it, but it will form a carboxylic acid definitely. So it will turn into a CH3COOH plus 3 carbon atoms. So one of them will get converted into COOH group, and we will have CH3, CH2, COOH. So here you get same number of carbon atom compound, but here the CC bond actually breaks up and it occurs in presence of powerful oxidizing agent, and it forms a different kind of mixture of carboxylic acid actually. But if you have unsymmetrical ketone, then the ketonic group will go with the alkyl group which contain less number of carbon atom. This is the Popov's rule, and again you will get a carboxylic acid. Right. So as I told you that aldehyde undergo oxidation very easily. So it undergoes oxidation with mild oxidizing agent also, like Tollens, Fehlings and Bendix. So these are the tests actually you can use it to distinguish between aldehyde and ketone. So whenever you get a sample and you need to distinguish that whether the given compound is aldehyde or ketone, so you can actually follow any of these tests. So what is the Tollens reagent? First I am going to explain you. It is actually this thing, AgNH3 whole twice OH. But how it is formed, we will be first forming it. So what happened, this NH4OH react with AgNO3, it forms AgOH which is precipitate, plus we get NH4NO3. Then we react this AgOH precipitate again with more NH4OH, and we get AgNH3 whole twice OH negative. This is our Tollens reagent. This is our Tollens reagent. Now, when we add this Tollens reagent to an aldehyde, suppose I have an aldehyde, I am going to react this AgNH3 whole twice, that is the Tollens reagent. I will do a reaction in an ionic form. So when we do that, then what products we get? This get converted into a carboxyl group, carboxylic acid group. We get silver, we get this thing ammonia liberated, and we get water. Due to formation of the silver, you know that in a test tube a silver mirror is formed. A silver mirror is formed. So whenever the silver mirror is formed, it actually confirms that the given substance you got was an aldehyde, because this test is not given by ketone. It is not given, means the Tollens reagent is not an oxidizing agent up to the mark which can actually bring about oxidation in ketone. Second is Fehlings reagent. In Fehlings reagent is actually a mixture of copper sulfate and Rochelle salt. So it is actually we have Fehlings solution A and Fehlings solution B. We just mix them and we get Fehlings reagent. Rochelle salt is actually sodium potassium tartrate. Sodium potassium tartrate. So we can also say it is a complex mixture of copper sulfate tartrate. So what happens here? Suppose you have an aldehyde. You are going to add this thing Fehlings solution. Let's say we'll write an ions which are actually present in it. Right. So they are going to oxidize an aldehyde group to this. It will form copper oxide and water. This copper oxide are something reddish brown precipitate. So whenever this reddish brown precipitate is formed, this means the oxidation of aldehyde has been taken place, because this is again not shown by ketone. The third is the Bendix reagent. It is actually a solution of cupric citrate. So again here you have an aldehyde, you have copper ions, you have hydroxide ions. They will again form and carboxylic ions. With that we will get copper oxide, again reddish brown color. So appearance of again reddish brown color indicates that the oxidation of aldehyde has taken place, because ketone does not show this kind of reaction again. So this is what is an oxidation of aldehyde and ketones. So whenever you need to do an oxidation of ketone, use a powerful oxidizing agent, because mild oxidizing agent has no effect on ketone. So this is what is an oxidation.